Today, we are not here to discuss the gleaming decks of supercarriers or the nuclear-powered ghosts lurking in the oceanic depths. Instead, we are setting foot on the scorching sands and treacherous littoral zones, where every square meter of terrain carries the immense pressure of a high-stakes struggle for survival. We are witnessing a radical tectonic revolution in the operational doctrine of the United States Marine Corps, the rise of the Amphibious Combat Vehicle, ACV, and its lightning-fast partner, the Joint Light Tactical Vehicle, JLTV. Ask yourself one core question. Why, after more than 50 years of absolute loyalty to heavy-tracked systems, did the U.S. Navy and Marine Corps decide to scrap the legendary AAV 7 inches favor of an 8x8 wheeled architecture for a machine weighing a staggering 35 tons? This is not a routine hardware update. This is a cold, calculated, and decisive admission. The era of old-school amphibious landings, slow, loud, and lumbering, is officially dead. In a world saturated with long-range anti-ship missiles, suicide drones, and improvised explosive devices, IEDs, with horrific destructive power, if you move slowly, you are no longer a warrior. You are an expensive stationary target worth millions of dollars. The Pentagon required a predator capable of swimming across open oceans from beyond the enemy's visual and radar horizon, and the microsecond its tires touch the sand, it must accelerate with the velocity of a specialized racing vehicle. Today, we will perform an exhaustive surgical autopsy on the ACV. We will dissect its 700 horsepower heart, the algorithms of its central tire inflation system, its V-hull architecture, and specifically, the way it synchronizes with the JLTV through a digital neural network to create a multi-domain pincer that is virtually unstoppable. To grasp the tactical genius behind this pincer, we must first descend into the mechanical viscera of the lead performer. Let us begin by examining the internal organs of the ACV to understand why it is considered a marvel of modern power-to-weight engineering and fluid dynamics. 1. The Iveco cursor. 16 heart. Metallurgy meets oceanic superiority. The lethality of the ACV is anchored by the Iveco Cursor 16 engine, a masterpiece of modern combustion engineering delivering a staggering 700 horsepower, twin turbocharging, and peak torque. This system allows the vehicle to maintain maximum power even while battling the immense drag of seawater, a medium nearly 800 times denser than air. It provides the consistent energy required to drive two high-performance rear water jets, enabling the ACV to maintain a steady swimming speed of 8 knots even in sea state 3 conditions. Chemical shielding and closed-loop cooling. Every internal component is treated with a nano-ceramic coating to combat the brutal effects of electrochemical salt corrosion. Crucially, the ACV's cooling system is a closed-loop design, utilizing integrated heat exchangers within the hull to dissipate heat without drawing corrosive seawater directly into the engine block, eliminating the risk of salt crystallization that would lead to catastrophic failure in the middle of the ocean. 2. The 8x8 suspension and the magic of the Central Tire Inflation System, CTIS. Many analysts remain skeptical about the performance of wheeled vehicles on soft beaches. The ACV answers this through a sophisticated, algorithmically controlled tire system. Instantaneous terrain adaptation. As the vehicle transitions from water to a soft, muddy, or sandy shoreline, gravity and pressure sensors detect the change in surface resistance. The CTIS immediately deflates the 8 massive tires, increasing the ground contact footprint by over 300%. This allows a 3.5-ton monster to glide over fine sand and littoral silt that would swallow traditional wheeled vehicles whole. Lightning strike velocity. Once the ACV reaches solid ground or paved roads, the system takes less than 60 seconds to reinflate the tires, pushing the top speed to 65 miles per hour, 105 kilometers per hour. This is a life-or-death tactical advantage. The ACV can seize a beachhead and immediately strike 60 miles deep into enemy territory in less than an hour, rendering any enemy counter-battery fire obsolete as it hits a vacuum. 3. V-hull architecture and blast mitigation engineering. The brutal reality of modern warfare is the prevalence of mines and IEDs. The ACV is engineered to survive explosions that would vaporize older armored hulls. Explosion dynamics. The bottom of the vehicle is sharpened into a deep V-shape. When an anti-tank mine detonates, this geometry deflects the kinetic energy and lethal fragmentation away from the hull, rather than allowing the energy to punch through a flat floor. Kinetic isolation. The 13 Marines inside do not sit on the floor. Their seats are suspended from the ceiling using a sophisticated system of high-tension cables and hydraulic dampers. When a blast occurs, the floor may buckle or deform significantly, but the Marines remain isolated in mid-air, protected from the lethal vertical acceleration that causes spinal and pelvic trauma in traditional armored vehicles. Survival is the foundation, but intelligence is the ultimate weapon. The ACV is powerful, but it requires an agile companion to act as its peripheral nervous system. This is where the JLTV enters the frame. 4. The TAC, 4i suspension, the conqueror of forbidden lands. The JLTV is not just a modern Jeep. It is an independent, mobile sensing entity. Its TAC 4i suspension system allows it to adjust its ground clearance by up to 20 inches. The vanguard role. Within the formation, the JLTV always runs ahead of the ACV. It utilizes surface scanning radar and infrared sensors to detect potential minefields or anti-tank traps from a distance. This information is not transmitted via voice. It is encoded into digital data and beamed directly to the control screens of the ACV commanders, trailing behind via the Link 1-6 network. 5. Integrated sensors and firepower. The eye and the gun. The JLTV is a miniaturized long-range fire center. Equipped with a remote-controlled weapon station, it can carry javelin missiles or heavy machine guns. Target designation. The JLTV detects enemy armor or fire nests from 2-5 miles away. Instead of firing immediately and compromising its position, it paints the target with a laser and transmits precise GPS coordinates to the ACV-30. The ACV can then engage the target with its 30mm cannon from a concealed position, neutralizing the threat before the enemy is even aware of the JLTV's presence. When the ACV and JLTV combine, they are no longer two separate vehicles. They become an integrated multi-domain strike ecosystem. 1. The sensor-to-shooter protocol. In a modern landing operation, the JLTV is often dropped onto the beach by heavy-lift aircraft like the CH-53K or LCAC hovercraft first to conduct reconnaissance and establish a communication mesh, piercing vision. As the ACVs swim toward shore from 12 miles out, they are not blind. They possess the entire enemy defensive layout thanks to data provided by the JLTV. The ACV knows exactly which bunker is active and where mines are located, allowing for proactive maneuvering before its tires even touch the sand. 2. Tactical simulation. The San Carlos flanking maneuver. Scenario. An adversary has established a mobile coastal cruise missile battery, protected by light armored vehicles and suicide drone swarms. Phase 1. Covert infiltration. The ACVs swim to shore under the cover of night in total radio silence. The JLTV utilizes its portable electronic warfare (EW) suite to jam enemy short-range surveillance radars, masking the acoustic signature of the Cursor 16 engines. Phase 2. Sudden breakthrough. Immediately upon hitting the sand, the JLTV hits 70 miles per hour, flanking the enemy position to act as a decoy and spotter. It forces enemy defensive units to reveal their positions. Phase 3. Total annihilation. The ACV-30 engages from the front with its 30mm Bushmaster cannon using airburst munitions. The enemy is caught in a lethal crossfire, precise 30mm fire from the ACV at the shoreline, and javelin anti-tank missiles from the JLTV at the rear. The A2 AD battery is completely wiped out in less than 15 minutes.